Hello, everybody. Hold on one second. Hello, everybody. I've got the intro so that in case people watch on YouTube, everything works as well. All right. Now we have one day, one session left, I think, to wrap everything up. We have done sort of the theoretical side of a probability distribution with the raffle and the game of chance examples. Just summarize sort of very shortly what that looked like. I think I still have it open actually. So practical versus theoretical, if you remember yesterday. So theoretically, I have this perfect probability that I can calculate for all possible outcomes, giving me my probability distribution. But in reality, most situations are too complicated for me to even bother, or it's literally impossible to find those perfect probabilities of what to expect. What we then do is we can just repeat the experiment over and over and over, uh, hopefully enough times, calculate frequencies, looking at, well, relative to, well, based on how many times I repeat the experiment, I could get the different outcomes a certain number of times. Make a table, and then relative to the total, I get these relative frequencies. So we did this yesterday, right? Then I can use these relative frequencies to approximate the actual theoretical probabilities that are behind the scenes. And the more repetitions I have, the closer I'll get to these the actual probabilities. And I can then calculate something like an expected value and so on. So let's do an exercise. No, not open. Next exercise that is based on this, and we'll introduce what we have to as that exercise happens. The one I want to look at is the next one on the list, exercise 7.4. Let me just check if everything is looking, sounding good. I never know. There we go. 7.4. A developmental psychologist surveyed 15 single senior citizens living in private apartments. Each participant completed the questionnaire on the number of telephone conversations they had in the last day. And here were the answers. Some had a lot, some had none, and some stuff in the middle. We want to look at the frequencies and then look at the relative frequencies by way of percentages. Okay, now I'm just going to screen my book to the side here, random line, so that I can see and hopefully you can, of course, look at the book and my screen at the same time. Why not? So the range of values that we get, range of values, seem to be from 0 to 7. That doesn't mean that 9 conversations aren't possible, but I have no reason to look at numbers further on because I don't have any values. So what we call the collection, let's write it out here, the collection of actual results, outcomes that we got are called, or the collection is called, the sample space. Sorry, not the sample space, just the sample, no space. If I look at this and compare it to the term sample space, these are different. Sample space is the sort of theoretical collection of everything that is possible. When I actually now run the experiment, get some results, that collection of results we call the sample. And based on this sample, this evidence that I've collected, I can hopefully figure out what does this look like. Now, just to clarify, we should have probably led with that. What is an experiment? What is the experiment in this case? The experiment is, uh, let's say, choose a random person from this single senior citizen possible list. Random person, as the question specifies, what kind of person, and uh, let's just say get their number of phone calls from yesterday. So I could get, oh, pick a random person, 0 phone calls. Pick a random person, maybe 0 again. Pick a random person, maybe 4. And we ran this experiment and got some sample values. So let's say here, define a random variable. Let x represent the number of phone calls uh, for a random selected person. I want to use enough words, but I don't want to duplicate the whole question, right? Someone who reads this should read the question first, and then if I refer to a person, of course that means a single senior citizen living in a private apartment. So I don't have to clarify everything over and over and over. Just have enough words to make it clear in combination with the question. All right. Then the possible, remember our goal is to approximate the probability distribution. The possible values of x, let's say, seem to be 0, 1, 2, 3, 4, 5, 6, 7, because that's as far as my evidence, what my evidence suggests. Now, in this case, I think it is impossible, near impossible, to actually calculate a theoretical probability distribution because there are so many factors that could determine the number of phone calls a person would make. It's too complicated. So even if it is possible, I don't even care to put in that effort when I know repeated runs of this experiment, creating the sample by just surveying more and more people, I'll get pretty close and close enough for practical purposes. Okay. So now we want to make a table here. Let's say here, say n, and it's going to range 1, 0, 1, 2, 3, 4, 5, 6, and 7. Now, of course, to make this not too tedious, doing it by hand, we only have 15 numbers in our sample. Of course, that is not nearly enough to be an accurate approximation for the true underlying probabilities. Of course not. But if we have too many, then we're going to have to use some software, and that's not the goal here. Just the concept is the goal. Let's check if we have questions here. No. my book to the other side covers Discord. Okay, so what often helps is some sort of tally system to count how many times do these occur. So I go through the list that I'll show you one more time. I go through the list here, 5, 0, and so on, and make a little mark every time I see the number. So 5 occurs, then a 0, then 2, then 1, then another 1, then 0, then a 1, then I need to keep track of where I am. I think it's a 0, then a 3, then 2 more 1s, that's 2, then a 4, then a 3, and then another 4, and then a 7. Hopefully I did that right, but we can now count, right? We should have 15 little tally marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. Okay, good. So you don't have to do the tallies, but it is an option, especially if you have a lot and they all easily blur together. Even these 15, moving my head back and forth, it got a little blurry very quickly. So let us just move the windows. Seem to be some breakup issues. I'm not running anything at the same time. It's just my wonderful internet, right? It's wonderful.
I think it's fixed now.
Okay, good. No, it's impossible for me to tell, so do let me know when that happens. It's yes, I won't criticize the internet provider, but it might be my modem, who knows, right? But it's nothing on my computer that I can see, so just let me know. Okay, so now let's go with the frequency. I'm really just putting a number on the tallies, right? So I saw five times 0 occurred, 3 times for that one. This one was only 1, so that's a tally, and that's a 1, right? Not the same thing. It's like night and day, right? 2 times there, 2 times for a 4, 1, 5, 0 sixes, and 1, 7. So even though 0 sixes occurred, I can't skip that. I have to cover everything in my range, which seemed to go from 0 to 7. So then we can add up the total here, and we should get 15, 8, 9, 11, 13, 14, 15. 15, so it's good. Good check. If I don't get 15, then I missed something, right? But if I do get 15, it's not a guarantee that I'm correct, of course. Then my relative frequencies. Now, 15 is a little bit unfortunate, so I'm just going to do fractions here. It's going to be 5 out of 15. Squeeze them in here. 3 out of 15. Because if I do decimals, it's going to be a repeating decimal, and I don't want to round things unless it's a final answer. But I'll squeeze them in. Well, 0. Well, 0 over 15, sure. 1 over 15. You can test that. Of course, it's going to add up to 1. So this is just my test. Am I sort of on track? Yeah, it looks okay. It's not a guarantee. So then these are my approximations for the, let's say, true theoretical probabilities, probs, if you will. Okay, that's what the relative frequency is used for. So that's part of the question. Make a frequency table, including percentages. Okay, fine, fine. They want percentages. We'll give them percentages. But I'm going to have to use a calculator. Not for all of them, right? This is a third, this first one. So maybe we'll do here percentages. So this will be a third to this. Oh, a third. That's a lot of zeros. Wow. So 33. Let's go 2 decimals. 33%. over 15 is a fifth, so that's 20%. 1 over 15, I don't know, let's say. So I'll calculate that, and we see it is, move it twice, 6.67%. 2 over 15, let's show that too, why not? Just to be sure, right? You don't want to make a little mistake now. But yes, I just doubled the previous one, 13.33%. 2 over 15 I've seen before, 13.33%. So just be aware of what the question is asking, how it wants you to present the information. 0, of course. 1 we've seen before, 6.67. And you can add these up. They should be 100% or very, very close. Of course, we rounded a little bit. So depending on how you round and the numbers involved, you might be off by like a hundredth here. Just give me 1 second. I'll be right. Yeah, something does seem a little off in my YouTube stream. See, hopefully it records correctly, and then if there's any hiccup, um, the upload of the backup on YouTube should be hopefully okay. Hopefully Discord looks don't really seem to work. Mouse doesn't work like it should, but we'll keep going. Why not? Get everything in today. So now they also ask, make a histogram. Now a histogram is just a fancy word for the for a specific bar graph coming from the frequency table. Now we've seen the bar graph before when it concerns frequencies or relative frequencies or the percentages. These are really all equivalent, and we make the bars touch. They, of course, want to make a new word for that, and they call it a histogram. So let's draw this and see what it looks like. Now I'm going to use a new page so that I don't scroll up and down and get dizzy. So let's do that over here, our histogram. Now people abuse the technical requirements of a histogram to the, oh, come on, point where it's really not that big a deal. You can use relative frequencies on the vertical axis. You can use frequencies. You can use the percentages, whatever, doesn't matter. Now, it doesn't really matter. We can offset this to make it a nicer bar so it doesn't sit on top of this axis. It really doesn't matter what you do here. The goal is to make it visually uh, clear how these values are occurring and what, just visually summarize the table. So let's go with a percentage. Sure, let's go with percentages. You can use any one of these columns. 0, I have a 33% bar, and that is actually my highest one by far, right? So I can make that maybe nice and big. Let's say maybe give myself some room here. Be handling this, so let's say that's 33%. Then one phone call occurred 20% of the time. That would be 20-ish over here, maybe. Again, if you draw your histogram and they don't touch and you want to make them super thin bars, Technically, they have to touch, but it's more of a just a visual preference than anything else, I guess. I don't want to get into the technicalities. Yeah, they technically should touch. Sure. Yeah. Number of phone calls two occurs 6% of the time, more or less. So that was 20. So that's around 10. So six maybe over here. And you can of course clarify that. Oh, that's 20%. That is 6.67%. And then the next one, 3 is 13, double the previous one. Then we have for 4 another bar of the same height. 5 we have a low bar again. 6 is empty, so there's technically a bar there of 0 height. And then we have a 6 again. Because often when you just want to quickly understand the information that we obtained, looking at a graph of some sort is definitely convenient to convey information. Now, this is maybe trying to resemble a distribution behind the scenes, a perfect theoretical distribution. Maybe it goes down like this. As the number of phone calls increase, the probability goes down, right? But you see, because we have a small sample, it's not perfect. We maybe got underrepresented on the twos and the sixes. Maybe they should sit more in line with a graph like that. Who knows? We don't know. But the more repetitions, the bigger our sample, the closer it might get and start to resemble something smoother. And then we can see, oh, that's the underlying distribution. Right now we only have 15 because we wanted to do it by hand, but it is still trying to represent that information. Okay, so that is exercise 7.4. Now, that's good. When we have a distribution, whether it comes from a sample, whether it's the theoretical one, doesn't really matter. Often it can take many shapes. It can be more of a bell curve. And of course with little bars, right? Because we're approximating things. Might not be perfect, but it's trying to approximate maybe something like that. Bell curve happens very often, or it could be a little bit more lopsided, biased to one side, whatever the sample is suggesting. There's some values that I want to analyze. When I look at either one of these, the position is sort of dominated by sort of the center, right? Most of the sample values that I get sit here in the middle for this distribution. For something that's a little bit more one-sided, most of them sit over here, sort of pulled towards the quote-unquote center where most of the values occur. It doesn't actually have to be the middle, but I can calculate a number to represent where do most values occur, so that when I run this experiment, what would I expect? It's just another spin on the expected value, and we'll make the connection soon. But by just looking at my sample, I have these 15 values, some frequencies, they occurred over here in my question. How can I use that to determine, well, what do I expect is going to happen if I make another, if I survey another person, one more? What do I expect? Do I expect 7? No, I expect something that is close to this center, and we have to define what that means, of the underlying distribution. Close, I expect, visually looking at this, 0 to 1 is the more likely ones. I could get something extreme, but most of the time I won't. Most of the time I'll get zeros and ones. So we have different numbers to represent this key aspect of the sample and what it suggests for larger samples and the random variable and the experiment as a whole. So we call it measures because I've used this word before. A measure is, whoopsie, don't do that. A measure is a number a single number that tries to capture the whole picture, tries to represent all the information in a single number. And the information that we try and capture first is where are most of the values occurring. So they call it measure of center, central tendency. What else could they call it? That's it. Just where are most things occurring? Not what does the shape look like, just if I run it again, survey another person, what's likely to happen? So we have the what might be obvious one, and that is the average. Average. Also called the mean. Why? Because in statistics they like to use new words for things that already have words. Who knows what? The average. So it's exactly the average that you think. If I ask a random person, how do you calculate the average of some numbers? You add them up and divide by how many there are. That's usually the response. How many there are. Doesn't have to be uh, other words than that. Let's just see here. What do I want to do? I don't want to do any of that. Knife. We are, let me say it by now, just before I forget. The exercise 7.5 and 7.6 is something that I have to do face to face, just to illustrate the fact that frequencies approximate probability distributions. We are happy to skip it because we already have the idea. Measures of center, there we go. Measures of center. So let's take something other than the phone calls. Let's take an example. I'm actually not going to waste your time by just copying what the book says. I'm just going to make my own similar example. Let's look at house prices in a certain neighborhood. We look at some house prices. Now, there is an underlying probability distribution that determines what the price of a house is likely to be and so on. I don't know what it is. There's so many factors that determine house pricing. It's impossible for me to perfectly represent, calculate probabilities. It's not going to happen. So let's suppose we have a sample of house prices. We look at the neighborhood. Some houses have been sold recently, and we look at a sample. Let's say 5 of them. Now it depends on the neighborhood, of course, and the country and the city and all kinds of things. So let's say we have one house that cost 500,000. Let's suppose we have one that cost 480. Let's suppose one cost sold for 600. Let's suppose that's 3 of them, right? Let's suppose we got a little cheapy, 400. Sadly, that's not cheap at all. And let's suppose we got another 500. Just to make it simple, big nice numbers, easy numbers, right? Then the average or mean house price is simply add them all together, exactly what you would think, over how many there are, and there are 5. Let's calculate that and see what we get. Not supposed to be difficult at all. 500 plus 480 plus 600 plus 400 plus 500. Close the bracket, divide by 5, done. Random line aside, I got 496. So that means 496,000 is the average house price. So this tells me, now of course there's a lot of factors. It depends on the neighborhood, uh, but house prices are going to differ. That tells me that if I pick a random house, it is more likely to have a price close to this average than far away. This does not, let me just have a disclaimer here. This measures of center, this average, does not capture all the information. It is impossible to capture all the information of a complicated situation by way of a single number. It is just a first step. There are other measures that need to be combined with this to really create a full picture, but those are more complicated. We're just taking a first step. So let's write down a sentence here. Uh, if we select a random house, of course, in the neighborhood and wherever I'm looking, we can expect its price to be close to 6,000. Some are obviously going to be more, some are going to be less, maybe a lot more, a lot less. But on average, most of them be around this. It's where it's positioned. So if I look at maybe there's a bell curve deciding or behind the scenes telling me how likely house prices are to go from, let's say, 100,000 to uh, 2 million. It might not be perfectly symmetrical. That's okay. My center is going to sit at this average. Of course, I need a bigger sample to really accurately approximate that, but that's the idea. All right. So this is one. It's great. Average. Everyone knows and loves it. It's used all the time. By far the most common and I would argue the most important measure in statistics. Absolutely. It's used all the time. And a big goal of statistics is to approximate this mean, this average. And it's not a simple endeavor. Okay. I'm actually just going to make an observation on top of this. Let's suppose we add one more house. I'm going to use a color. Rusty pink. Let's say we do one more, add one to our sample, add one to our sample to now have a sample of 6. And it's going to be a $2 million house. Someone moved in, someone rich and famous. They like the neighborhood. It's cheap for them. But they built their own house and then they decided, no, I'm going to leave. And they sell their house for 2 million because it was a fancy house. What happens? Well, now I have to put this 2 million in my list. So 2 million or 2,000,000. And this is going to get another 1 added because my sample is 1 bigger. So now what do we get? Let's see if I can just update this. Can I? Now I have to add 2,000 because I'm working in thousands. So 2,000 thousandths is 2 million. And I have to divide by 6. And then we get 746,067. This is in thousands, right? So what happened here? This extreme house is really distorting the picture of what is really happening in this neighborhood. Now someone could look at this sample, assuming it's big enough or whatever, look at the sample and say, "Oh, a house goes for 746,000 on average. That's what I can sell my house for." No, it's not. We're really realistically still looking at 496-ish. this $2 million house messed everything up. So the downside of this average, this mean, is that it is sensitive to extreme sample values. Call them outliers. They are possible, though it's extremely rare to find a $2 million house in this neighborhood. Not impossible, but rare. And those outliers, those extreme values, are not representative of what is happening in the neighborhood. Yet the average incorporates them in its calculation, and because it's so much bigger, it's an order of magnitude bigger than the other houses, the average answer is being pulled in that direction when it kind of shouldn't be, right? So it's not necessarily representative. Now, this can be overcome by just taking a large enough sample, but the issue of identifying and excluding outliers is not a simple one and can be very important. So how do we get around that? I'll erase my note here. Get around that when we suspect that this is happening. What am I doing? Change the color. We get around that by calculating the median as another way to represent the information by way of a single number. The median is the, let's say, the actual middle. Whoops, I can't spell. I can't spell. I can't speak and write, apparently. The middle value that occurs. So I'm going to list my numbers with this pink one in order. So the smallest one is 400,000. List them in order. 400,000, 400. Then I had a 480. Go to memory. That one's done. That one's done. Then I had two 500s. 500,000. That looks like an 8. It's not. Another 500,000. That one is done. That one is done. Then my 600 and my 2 million. And my 2 million. List them in order and then look for the middle. The middle is 3 in from the side, 3 in from the side. The middle sits right there. So both of those 500,000s are in the middle. Then if that happens, we have the middle of the middle is 500,000. So the median is $500,000. And we see that if we make this 10 million, the middle doesn't change. The median is not being pulled away from the center value. It's not sensitive to extreme values. So that's how we can overcome the possibility of an outlier skewing the information, distorting it. It's an alternative. Now, I just want to clarify here. Let's suppose we had 400, 480, 500, 520, 600, and 2,000 thousands. If I have an even number of values, these are the middle two. It's the middle of the middle. I simply average these two. In the middle, get 510. If I have an odd number of sample values, for example, 400, 480, 500, 520, back. Apparently it doesn't want to go back. Oh, it did go back. Man, 520, maybe a 600, maybe that's it. Right now I have 5 values. There's a single guy sitting in the center. That is the median. So there's slight variations in the calculation or the process between having an even number of values to work with versus an odd number. Now, in my original example, I had an even number, but both the middle ones were exactly the same. So then the average of the two is that number. So just be aware of I handle things a little differently depending on how many numbers I have and what the center looks like. If there's a single number in the center, that is the median. If there is an even number, then I really have two in the middle. And I'm looking for the middle of them, which is the average. Now, some people argue that, oh, this should be different, but most of the time they just take the average. Okay. Then lastly, we have one that is worth mentioning, but not really that common uh, in this group of three. Lastly, we have the mode, not hard at all, but sometimes it's rare that this is used in preference above the other two. I can't even think of a scenario. It's just another number that can be used to describe what is happening. It is simply the value, sample value, that occurs most often. So let's suppose I have a sample of 400,000, 500, no, it was 480, right? My original 480, 500, 500, can't remember. Let's go with this. Then the mode is the one that occurs most often. It's 500,000. Two of them and only one of the others. Now the mode there might be more than one mode. If I have another 600,000 here, then they're both. Or if they're all singles and none of them repeat, then there technically is no mode. So it doesn't always, it's not always meaningful to talk about the mode, but sometimes it just adds a little bit more to the picture. And you see, sometimes they could be the same, sometimes they could be a little different. It really depends on the values. And if things are most often, where's my better picture? Say, have a bell curve that's mostly centered, then the mean, median, and mode will sit pretty much on top of each other, especially if I have a lot of sample values. But if this bump is a little bit to one side, then looking at all three, uh, they're going to be slightly off of each other, and each one then contributes its own little bit of information. Regardless, I have the mean, the average, I have the median, and I have the mode. And usually the page where I ask you to calculate these given a sample, usually quite straightforward page to do. Now, if we look at exercise 8.1, it is the same as the other, the one we did previously, same sample values, and I can add them up. I can find the median. I can find the mode. Let's do it for this one. I thought that we would maybe squeeze everything in, and I already made tomorrow a Q&A session, but I think the best idea to rush things. Regardless, uh, there will always be a video of this last bit in case you already made other plans for tomorrow. But I think weighted average we can leave until tomorrow, so we can take our time, and it'll only take like 10 minutes. Okay, so we have our sample. We want to calculate the mean. We want to calculate the median. Find the mode. The mode doesn't have much calculation behind it. All right, so for the mean, the average, I'm adding them all up and then dividing by how many there are. Now, just in case I make an arithmetic mistake, I want to show here that I understand what to do. And I emphasize that I'm adding, whoopsie, them all, even though it is tedious. And I lost my place now. 502, 1, 1, 0, 1, 0, B, 1, 1, 3, 4, 7. Because what if I make a mistake in the calculation? Now I get 0. But if I show that I understand how to calculate this, then it's easy to see, oh, I just made a little calculation mistake. You should get part marks for the understanding, maybe. If it's worth 2 marks. And I'm dividing by 15. Let's squeeze it in over here. Let us see. Let us see. Let's do it. 5 plus 0 plus 2 plus 1, 1 plus 0 plus 1 plus 0 plus 3 plus 1 plus 1 plus 4 plus 3 plus 4 plus 7 divided by 15. Hopefully I did that right. Even the 15 numbers, they blur together so quickly. So the challenge here really is to keep track of everything. Oh, I didn't do two equal signs. Whoopsie. Let's see if we can edit that. Are you there? 2.2. Now again, the mean is just an indication of what is likely. Actually, I'm just gonna didn't leave myself enough space here. And if I look at the range from 0 to 7, the mean sits over here somewhere, right? 2.2. I'm never going to get 2.2 conversations. Oh, I had two conversations and then a fifth of another one. I just stopped mid-sentence. No, of course, I can only get integer values. The 2.2 is simply an indication that it's sitting close to 2, so I expect around 2 conversations. And this wasn't obvious from looking at the distribution at all, right? It wasn't obvious. I thought 0 because it is the highest bar. No, but the mean tries to capture all of the information and combine it to give me a better picture of what is happening and what I can expect. 2.2. So I expect the number of phone conversations, if I survey a person, to be around 2, maybe a little more, sometimes 3. Of course, it's not going to be every time 2. It's going to average out to around 2. Sometimes it's going to be a 7. A lot of the times it's going to be a 0. But overall, it's going to be on average around 2.2. And if I have more, then that number will just be a better representation. Median, well, let's leave this answer blank for a second because I have to arrange these guys in order. That's going to be 0, 0, 0. I see that 0. There's all the zeros. 1, 1, ones. I have to arrange them in order. This 2. Is there 2? No. Some 3s. 1, 2 of them. 3. There is a couple of 4s. 4. There is a 5. There's 5. No 5s and the 7. Let me count. Do we have 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Now I'm looking for the middle. I can go 7 in. 1, 2, 5, 6, 7. 7 in. 1, 2, 3, 4, 6, 7. And the center guy is right there. So 1. See how they're quite different. Quite different. And it's because I don't have a large sample. If I had a larger sample, they would be most of the time much closer to each other, especially when I have where's my shape? I moved it. It's somewhere. I don't know where it is. Especially if I have a sort of a bell curve, which is very, very common, they'll be very close to each other. The mode, I'm simply counting which one occurs most often. It's a 1. The one occurs 5 times, where the others do not. So my table, my frequency table actually helps me here. I can see. Did I do this right? I don't know if I did. I got 5 zeros. Maybe it was a different question. I thought it was the same question. I'm confused. It's a different. Maybe it's a different question, or maybe I didn't do this one right. Yeah, no one said anything. Who knows? For this question, 8.1, I certainly only have 3 zeros, right? Did I do the other one wrong? Way back when we looked at C's. Yeah, I seem to have done something wrong. This said anything? Yes, it's okay. All right. So let's go back here. I'll double check, and then if I did something wrong, I'll update the video. So we do have a little more to do. Weighted average. There's an interesting question about grade calculation, but obviously we are out of time for today. So I do have tomorrow as a Q&A session. Totally fine if you have other plans. I'll post the video anyway, but do make sure you do cover that last little bit, and that wraps up the part 2, which is halfway. Nice. All right, any thoughts or questions at this time? I think there was a mistake somewhere. I'll fix it. So just double check later on. Uh, I'll double check. I can't do it while I'm talking as well. I need to go and check. Okay, until next time then.